Hi guys, welcome back to our part two of our Introduction to Quantum Physics by our invited speaker, a rising junior at Great Neck South High School, Xingzhi Li. Okay, so we are currently on our Q&A part. Our first question for you is, what are some good resources, for example, books, websites, YouTube channels you would recommend to someone who's curious about astronomy or astrophysics?
Okay, so for astrophysics, okay, so like if you like actually stuff curious about astrophysics, I think the best is just search up like the stuff you're curious about on YouTube, and usually there will be some guy explaining to you, and they will probably be like more clear than some even teachers. Okay, now for books, I read this one book for astrophysics, no, but I read this book on QED, The Strange Theory of Light and Matter. It's by Richard Feynman. It is quite interesting if you want to know more about electromagnetism, and that was um for astronomy. I don't know if it plays a big part in electromagnetism. And oh, always there's a best friend out there. It's called ChatGPT. Like it actually helped me with like a lot of questions with physics. And I think ChatGPT actually is like the really good at basically everything. So probably ask him as well.
Okay, thank you very much for sharing. Our second question for you is how do you balance, for example, academics, extracurriculars like robotics, and track with your passion for astrophysics?
Oh, okay. So just as I kind of quit robotics, so we don't talk about that part, but it's fine, it's fine. Um try okay. So like the reason I do like exercises is so that after a day of school, I can't even do any work. And also it's kind of nice hanging out with friends and like balancing like I really just do it on my free time. I mean, the basically right, like if it's if you actually enjoy it, just learning it or for
Mhm.
fun then it really wouldn't be like a chore or a task. It'd just be like just spending your free time doing it. Yeah.
Okay, thank you. We also got some questions on quantum physics content.
Oh, hmm.
Our first
Yeah.
question is, can you please briefly explain in simple terms what quantum physics studies compare to like classical physics? Like compare and contrast those two different types.
Okay. So like the main difference between classical physics and quantum physics
Hmm.
is that the quantum physics is there's a lot of like unknowns and there's really like it's like maybe all the physicists are trying to find equations to like link all the fundamental forces together but there's really like a lot of stuff that is just different that's just like you just have to accept that you just don't know and sometimes like that could like maybe like bug some people because like like even the top scientists just say like yo we don't know what's happening here but sometimes it will be also be intriguing just be like wow that's pretty cool like we might never know so that's the main difference between quantum physics and traditional physics is that there's a lot less sort of laws and equations and there's a lot more like theory and concept.
Okay, thank you very much. Um, so far as I know, a lot of people are interested in like black holes, as well as like time dilations. So how do quantum mechanics principles kind of apply to astrophysics and like black holes? Like what is that link? How does it relate to each other?
Oh, okay, so for it's a for black holes and time dilation, that's really to do with the theory of relativity. And I right, so like for this presentation, I don't didn't go into it at all because the quantum scale is quite different from the like the actual physics side and the whole like can of worms with gravity and the all paradoxes it conclude it really deserves like its own different stuff like whole like a video like or like Zoom sessions covering it.
Okay, thank you very much. We'd definitely love to hear more about it on that aspect. Um,
Oh, okay.
I remember you mentioned about like the four fundamental forces. So in your opinion, do you think quantum physics will eventually help us like unify all of the fundamental forces?
I mean, like, okay, I mean, okay. So for it's really okay. So the reason why there's no unification is because of gravity. So there's equations unifying the three fundamental forces: the strong nuclear force, the weak nuclear force, and electromagnetism. and then there's equations for gravity, and those two doesn't combine. So if you like, there's theories that unify all of them, like the string theory or quantum loop theory, but can't really test them right now. So yeah.
Okay, thank you. Also, I remember you talked about like the uncertainty side of quantum physics. So how does the uncertainty principle kind of affect our ability to measure those particles?
Um, I mean, it's uncertain. Wait, so like, okay, so like, there's this thing about like, never really know where electron is. Like, technically, like all the orbitals and like shells kind of like just look like just fields and like the probabilities, like the density of the field. So the only way we know where electron is, but like for example, like taking a snapshot of it,
Mhm.
and also like if you heard the electron double slit experiment where it's wave duality and like interference is like we never know what actually happens because the moment we put observers, the electrons actually decided which slit it goes through, and that's like some uncertainty on like the series part. But yeah.
Okay, thank you very much for your explanation. Our next question is, what are some like real world applications of quantum tunneling?
Okay. So for quantum tunneling,
Mhm.
like one second. Let me search like that term up. I don't even know what's
Take your
happening.
time. No
Wait,
worries.
quantum tunneling.
But we
Quick.
definitely learned a lot from your
Um,
presentation when you talk about like the four fundamental forces and how those kind of, compare contrast with each other. How does that link to our modern understanding of physics? That's really, really helpful. And
um,
also, Sheen's,
okay.
yep.
Sorry.
Okay,
Sorry.
no, you continue. Sorry for you.
Sorry about that. But so quantum tunneling. Okay, we just gonna put it. Okay, just I don't really know what some quantum tunneling is happening with them. I know quantum entanglement. And like people use quantum entanglement for like data is like traveling data like encryption. Like that's pretty cool. But like that's all that I know.
Okay, thank you very much. Let's see, what are some other questions? Okay, one question is, how do physicists study particles that are like, for example, too small to see directly? Do they use tools, for example, some like computational tools, use some coding to make that connection? Can you please elaborate on that?
Okay. So. There's a okay, so like to a lot of time it's just just use computer to like generate stuff. But to actually like discover these particles, there's this cool laboratory called CERN. I think it's in Europe somewhere, like hopefully it's in Europe. But basically all they do all day is they this very big tunnel that's actually like bigger than probably an entire it's probably the size of a small like small street all they do is to smash particles together all day long and with enough speed and with enough particles eventually they will smash particles and they'll create new stuff and they documented it in their notebooks and that's really how like all the part we found it. That's how we found most of the particles actually on the table.
Okay, thank you very much, Xingzhi. We have one last question, which is
Mhm.
about like quantum physics applications to general public, for example, middle school students and high school students. So how can middle school or high school students get involved in learning more about quantum physics kind of outside of the classroom
You,
and utilize that resources?
Mhm. Okay. Like, if you like really have a subject that you're interested in, you could
Hmm.
like buy a book. I mean, there's a lot of different books on a lot of different stuff.
Hmm.
Or like if you have like less time and just like have like 20 minutes a day, just like watch a YouTube video. That's actually how I learn a lot of stuff from it. Yeah.
Okay, thank you very much. Also, personally, I have a question that is quite interesting because as you know, I'm a rising senior in
Mm-hmm.
high school, and last year, junior year, I was taking AP Chemistry, and we also learned about Coulomb's law, which is quite interesting. Force is related to like Q times K times Q1, Q2 over R squared, and Q1, Q2 are like the charges
Yeah.
of like elements. And also the R is like the radii between, of the distance between the radii of two elements.
Mhm.
So that also kind of links to quantum physics, right? Like how does it kind of relate
Oh, I mean,
to
okay, so like the whole reason why Coulomb's law like works, it's really because like the particles are exchanging like these virtual photons. I mean,
Mhm.
they're not actually exchanging photons in the photons that we could detect, but the theory is that they're exchanging the photons that either repels them if they're likes or they attracts them if they
Okay,
are. Hmm.
thank you very much, Xingzhi. Also, in addition to your presentation, a tool or a website that I would recommend would be the ISAO International Student Astronomy Organization, because we offer a lot of opportunities as well as a lot of, webinars and research presentations that are related to physics if students are interested in, specifically in astronomy. So please also visit our website at www.isaoleague.com. So yeah, stay tuned. Um, Xingji, thank you so much for your presentation, answering all of our questions. And also thank you all for joining us today. I hope to see you again on our next webinar.
That's